Okay, so this is going to be a follow-on to our first Foundry video and also our staking video. It's going to be follow-on to Foundry because we're mainly going to be using the cast command, and we're going to be performing the transactions on our staking token and our staking contract. So first thing I'm going to do is just create an env file, and I'm going to open that. I'm going to open bash, another shell. I'm going to fire up Anvil, and I'm going to take a private key and a public key from Anvil. So we'll just take the first ones. We're going to deploy both contracts from the same deployer, private key, deployer, public key. Copy this first here. Save that. Go back to our shell. Gonna load env file in to make sure we have access to those variables. Let's do it clear. So the first thing we're going to do is deploy our staking token from this deployer private key. It's just going to be forge, create, source, and the file is called staking token.sol, and the contract is just called staking. Private private key. Private key we have is called deployer underscore private underscore private underscore key. And there it is. So that's the deployed address of the staking token. So I'm just going to copy that and put it into our env. Say staking. Now we're going to deploy our staking contract. This is going to be the same command. It's going to be staking.sol. And we're also going to have to pass in constructor. It's constructor args. And we're going to have to pass in, it's going to be staking token. New source env again, just to load it. Here we go. So now our staking contract is being deployed to this address. Contract address, just to keep track of that. There we go. So we have both. We have our token deployed here, our staking contract deployed here. Just going to clear the shell. So when you go to a DeFi app, what you'll find when you're trying to deposit, say, tokens into a liquidity pool or something like that, you'll have to approve or you're trying to swap tokens, say, you'll have to approve the token first. So you're actually interacting with the token contract to do the approval and to say that this app or this DApp is allowed to swap my tokens, for example. And it's going to be similar here. What we need to do is we need to interact with our staking token, and we need to call approve on that and allow our staking contract address to have control over those tokens. We're going to use the cast command to do that. So the first thing I'm going to do is cast. To do that, we're going to do cast send. And what we need to do is we need to call it. We're going to cast send. So we're sending a transaction. Cast send is to send a transaction. Cast call, I should say, is to get information from a contract. So we're going to do it to staking token. Staking token address, we called it. And we're going to pass in the function signature, which is this. So it's approve and it's address and it's uint 256. So what this is we're saying send the transaction to the token address and look for this function signature here. And on that function signature, then we want to pass in what the first one on approve. If we were to go in here to staking token should do it. Yeah, we look here. We go and look for approve. There we go. You can see that on the function say approve, you pass in an address and a uint 256. So what you're saying is, I approve on this token for this address, which is going to be our staking contract, to spend this much of my tokens. And that's really what we're saying here. So what addresses are that we're looking for? Well, if we look here, we're going to say the staking contract address, which is called staking contract address. So we're just going to do it like this, staking underscore contract address. And I think we said that we would have 1,000,000 tokens. So we're going to say on this, we're going to say that we wanted to have 1, 2, 3, 4, 5, 6. There we go. So that's 1,000,000. Then we're going to say we're going to need the private key. Dash private key. And the private key is the deployer private key. Because the deployer, when we deployed our token, we said the message of sender, which is actually our deployer, has full control over this. So the only person who has any of these tokens is actually the contract deployer at the moment. We're going to say deployer private, and that should do the trick. So before I do this, I'm actually going to have to load our source.env again to ensure that our new variables are in there. Then back to this. So it's cast send to the staking contract. There's the function signature. It's the address. The address and the amount and the deployer. And there we go. So so that's our actual transaction there, haven't gone through. We clear. So now that we've said to the token contract that we're allowing the staking contract address. So we've said the token, we said to this address, or this contract I should say, that this address or this contract is allowed to operate on 1,000,000 of the tokens. What we need to do now is we need to just check it really. So we're just going to go cast call. And again, we're calling on the same. It's going to be the staking token because we just want to ask. There's another function on the staking token address. And the function is called allowances. Or it's allowance. An address and an address. So again, similar, if we go back to ERC20 and we search for allowance. Correctly. Allowance. There we go. We can see that our allowance function, you pass in the owner first, and then you pass in the spender. So in our case, the owner is actually going to be the deployer, and it's the deployer public key or public address. And then the spender is going to be the staking contract address. Contract, to spell it correctly. Yep. That should be it, because we're just doing a call. We don't need any private key. So we're saying call this contract with this, call this function on this contract and pass in the deployer public key, which is the owner, and who we've allowed to spend our tokens. And we should get that. And then if we take this, we just copy it. Function within this is called cast. That's 2 base. What I want to say is when we casted the base 10, what do we get? There we have 1,000,000, which is exactly how much we've said that we want the staking contract to be able to spend on our token. So that's just doing an approval, the first step of it. Clear. Rid of the ERC20. So we're done with our token and our approvals. We're going to switch over now to our staking contract. Save this. On our staking contract, we're going to call stake using cast. So what we need to do is we need to call the contract, the function signature, which is going to be stake, and it's going to be address, because ERC20 is the interface, but it's actually going to be address, EO1256. So I'll get rid of this. Let me see. So we're going to do cast, and it's going to be send because we're sending a transaction to the contract. So cast send, and the contract we're sending it to is staking contract address. And then the function signature is going to be stake. It's going to be address. Uint 256. Got to wrap it in. There we go. Mistake. And okay, so then what we're going to do is we're going to pass in. So we need to pass in our first parameter, which is the address of the token that we're going to stake. So we said, well, I think we call it staking token address. I'll just check that in the env file. Staking token address. Yes, that's the address, the staking token. how many we want to stake. Okay, so we're not going to stake the full million. What we'll do is we'll stake just one less because it's just easier to read then when we're actually when we're doing a call to check how many we've staked. Okay, then we're going to do private key, deployer, private key. That should be correct. And there's our transaction gone through. Okay, clear that. So we've staked 999,999 of our staking tokens into the contract. Now what we want to do is we want to call balances on the contract. So when we write in the contract, see up here we have our mapping, and it's called balances. So you want to check now what our actual balances are staked in the contract. So again, this isn't going to be a send, it's going to be a call. So when we cast call, and again we want to call this staking contract address, and it's going to be balances address, and it is going to be because it's a call and this is public, it's just going to be the public address of our deployer key. But because this is what we've used to actually stake into the contract. So if we do that, we get this here. And again, as with before, we go cast --2 base, paste it in, we go 10, and there we see that's the current balances in our contract. We staked in 999,999 of our tokens, and there we can see that we had them staked into the contract. And similarly, if we want to do unstake, going to be almost the same. What we're going to do, we go back up what we have here. So we're going to be calling. We're actually going to we'll go back to the stake. Go. Going to be unstake, and this time we're going to say. So again, it's going to be, we're calling the staking contract, and we're calling unstake on the staking contract with these parameters passed in. Staking token address, which is the same, but we're going to take out, we'll take out 876 just to leave something in the contract, whatever that is. And that should unstake the tokens. And there we go. There's our, and if we do balances again, okay, we'll try this again. We get a different amount left. So there should be a small amount left in the contract if we do cast --2 base this, and we do 10. We see there's 1, 2, 3 left in the contract, which is correct. We just left, I think it was 99976 or something like that. You can see that we've unstaked them. So when we were writing our staking contract and we were doing the rewards, we said that it was an ERC20 contract. So as it's an ERC20 contract, we can actually look into it. We can point at our staking our deployed staking contract, and we can look for balances of, or balance of, I think balance of. Find it there. There we go. And if we do this function signature balance of address, and we pass in the address of our public address of our deployer, we should see a balance of our rewards token. So not our staking token, because we're looking at the actual staking contract itself, and we want to see how many of the rewards token we're after issuing. We should get 1 per second, and we staked for, I don't know, 10 seconds or something like that. So I'm just going to do this again. So we'll do, it's just a call. So we are going to say so it is our cast call staking contract address, because that's what it is. Again, the staking contract isn't just our staking contract, it's also our ERC20 contract that we've imported, and we're issuing tokens. So it actually has this balance of address as it is in ERC20. We're passing in the address, and we want to say that's actually correct. That's our that one ending in 2266 is our deployer public key. Well, I think this should work. So see, there we go. Copy that. Again, we just do cast dash to base. And okay, so it wasn't 10 seconds, it was 168 seconds. So a few minutes. Yeah, so 168 is what we have of our rewards token, and then 123 is what we've left in the contract that we actually staked in. There you go. So we've deployed our two contracts. We deployed our staking contract, our staking token first of all. We then deployed our staking contract and we passed in the staking token as the stakeable token into the contract. And once we've done that, we were able to call our stake function by passing in the staking token and the amount we wanted to stake. So of the staking token, there was 1 million in circulation. We staked in 999,999. We then unstaked 999,876 just to leave some of the contract. When we checked in the contract how many were left, there was the right amount left. Then when we went and checked on the staking contract itself, the balance of the rewards token, we could see that we got one for each second.